aluminum wire is still permitted for use in homes, despite the problems experienced in the 1970s. The 1999 National Electrical Code, or NEC, had no restrictions on aluminum wiring in homes, and this has not changed in the NEC 2005. One exception to this rule is feeders supplying dwelling units, as those must be copper. NEC 2005 Article 310.15 addresses the connection of aluminum wiring. If the termination is by means of solderless connectors, then only connectors listed for aluminum wire are to be used. Solderless connectors listed solely for copper wire must not be used with aluminum. When aluminum conductors are connected by twist-on wire connectors, then the connector must be suitable for both copper and aluminum conductors. It is acceptable to use crimp-on connectors that are listed for joining aluminum to aluminum or aluminum to copper conductors. When aluminum wire is connected to terminals of devices such as switches and receptacles that are suitable for either aluminum or copper, then one must use the proper size terminal for the wire size. Other than that, no special marking is required at termination points. The use of aluminum wire is still common for branch circuits and feeders in commercial and industrial buildings. Let's delve deeper into the specifics of using aluminum wiring, focusing on NEC guidelines and best practices. First, it's essential to understand the history of aluminum wiring in residential applications. In the late 1960s and early 1970s, single-strand aluminum wiring was widely used in homes due to its lower cost compared to copper. However, problems soon emerged. Aluminum expands and contracts more than copper with temperature changes. This can lead to loosening of connections at terminals, creating a high resistance and potentially overheating, leading to fire hazards. Another issue is galvanic corrosion. When aluminum comes into contact with certain dissimilar metals in the presence of moisture, it can corrode. This is especially problematic where aluminum wire is connected to standard electrical devices not rated for aluminum. Due to these issues, many homes with aluminum wiring experience problems, leading to concerns about its safety. While the NEC has never completely banned aluminum wiring in residential applications, its use was greatly reduced, and stricter regulations were put in place to mitigate the risks. Now, let's examine the current NEC requirements for aluminum wiring. As previously mentioned, NEC 2005 does permit aluminum wiring in homes, with the exception of feeders supplying dwelling units, which must be copper. The key to safely using aluminum wiring lies in proper installation and the use of compatible materials. Article 310.15 of the NEC 2005 provides specific guidelines for connecting aluminum wiring. When using solderless connectors, only those listed for aluminum wire should be used. Connectors listed solely for copper wire are not suitable for aluminum because they may not provide a secure and corrosion-resistant connection. Twist-on wire connectors, often called wire nuts, must be suitable for both copper and aluminum conductors when connecting aluminum wires. These connectors are typically marked with the letters AL/CU, indicating their compatibility with both materials. Crimp-on connectors can be used for joining aluminum to aluminum or aluminum to copper conductors, provided they are specifically listed for this purpose. These connectors create a strong, gas-tight connection that helps to prevent corrosion. When connecting aluminum wire to terminals of devices such as switches and receptacles, it is crucial to use devices that are rated for both aluminum and copper. These devices are marked with the letter CO/ALR, which stands for copper/aluminum revised. The revised designation indicates that the device is designed to handle the expansion and contraction of aluminum and the potential for corrosion. It's also important to use the proper size terminal for the wire size to ensure a secure connection. In addition to using the correct connectors and devices, proper installation techniques are essential for aluminum wiring. Here are some best practices to follow. Firstly, always clean the aluminum wire with an antioxidant compound before making connections. This compound helps to prevent corrosion by creating a barrier between the aluminum and the surrounding environment. Secondly, when tightening screws on terminals, use a torque screwdriver to ensure that the screws are tightened to the manufacturer's specifications. Over-tightening can damage the wire, while under-tightening can lead to loose connections. Thirdly, after making connections, inspect them regularly to ensure that they remain tight and corrosion-free. If you notice any signs of loosening or corrosion, retighten or replace the connections as needed. Now let's consider the advantages and disadvantages of using aluminum wiring. One advantage of aluminum wiring is its lower cost compared to copper. Aluminum is more abundant and less expensive than copper, making it an attractive option for large-scale wiring projects. Another advantage is its lighter weight. Aluminum is significantly lighter than copper, which can make it easier to handle and install, especially in long runs. However, there are also several disadvantages to consider. As mentioned earlier, aluminum expands and contracts more than copper with temperature changes. This can lead to loosening of connections and potential fire hazards. Aluminum is also more susceptible to corrosion than copper. When exposed to moisture and certain dissimilar metals, it can corrode, leading to increased resistance and potential failures. Furthermore, aluminum is not as strong as copper, so it is more easily damaged during installation. Due to these disadvantages, aluminum wiring is not as widely used in residential applications as it once was. However, it is still commonly used in commercial and industrial buildings for larger gauge wires, where the weight and cost savings can be significant. In these applications, the risks associated with aluminum wiring can be mitigated through careful installation and maintenance practices. It's also worth noting that aluminum wiring technology has improved over the years. Modern aluminum alloy conductors are more resistant to corrosion and have better mechanical properties than the aluminum wiring used in the 1960s and 1970s. These improved conductors, along with the use of proper connectors and installation techniques, can make aluminum wiring a safe and reliable option for certain applications. In summary, aluminum wiring is still permitted for use in homes and buildings, but it is essential to follow the NEC guidelines and best practices to ensure its safe and reliable operation. Use only connectors and devices that are rated for aluminum. Clean the wire with an antioxidant compound before making connections. Tighten screws to the manufacturer's specifications and inspect connections regularly. While aluminum wiring has some disadvantages compared to copper, it can be a cost-effective and lightweight alternative when used properly. Remember to consult with a qualified electrician to determine the best wiring solution for your specific needs and to ensure that all work is performed in accordance with the NEC and local electrical codes. Let's further elaborate on the specific types of connectors and devices that are suitable for use with aluminum wiring, focusing on their construction and how they mitigate the risks associated with aluminum. Firstly, let's discuss twist-on wire connectors, or wire nuts. As previously mentioned, when using wire nuts to connect aluminum wires, it's crucial to use connectors that are specifically listed for both copper and aluminum conductors. These connectors are typically marked with the letters AL/CU. The internal construction of these connectors differs from standard wire nuts in several ways. The AL/CU connectors typically have a wider, deeper skirt to provide more contact area with the wires. They also contain a corrosion-inhibiting compound that helps to prevent oxidation and corrosion of the aluminum. The wire nut itself is often made of a different material than standard wire nuts to ensure compatibility with aluminum. When using AL/CU wire nuts, it's important to follow the manufacturer's instructions carefully. Firstly, strip the wires to the correct length as specified by the manufacturer. Secondly, apply a small amount of antioxidant compound to the wires before twisting them together. Thirdly, insert the wires into the wire nut and twist until a secure connection is made. Finally, tug on the wires to ensure that they are securely held in place. Next, let's discuss crimp-on connectors. Crimp-on connectors are another option for joining aluminum to aluminum or aluminum to copper conductors. These connectors create a strong, cast-tight connection that helps to prevent corrosion. Crimp-on connectors typically consist of a metal sleeve that is slipped over the wires and then compressed using a special crimping tool. The crimping process creates a permanent bond between the wires and the connector, ensuring a reliable connection. When using crimp-on connectors with aluminum wire, it's important to use connectors that are specifically listed for this purpose. These connectors are typically made of aluminum or a bimetallic material that is compatible with both aluminum and copper. They also contain a corrosion-inhibiting compound to prevent oxidation. The crimping tool must also be designed for use with aluminum connectors to ensure that the correct amount of pressure is applied. When using crimp-on connectors, it's important to follow the manufacturer's instructions carefully. Firstly, strip the wires to the correct length. Secondly, apply a small amount of antioxidant compound to the wires. Thirdly, insert the wires into the connector and crimp using the appropriate tool. Finally, inspect the connection to ensure that it is properly crimped and that the wires are securely held in place. Now let's consider the terminals of devices such as switches, receptacles, and circuit breakers. When connecting aluminum wire to these devices, it's crucial to use devices that are rated for both aluminum and copper. These devices are marked with the letters CO/ALR, which stands for copper/aluminum revised. The CO/ALR designation indicates that the device is designed to handle the expansion and contraction of aluminum and the potential for corrosion. The terminals of CO/ALR devices are typically made of a different material than standard terminals to ensure compatibility with aluminum. They may also be plated with a corrosion-resistant material such as nickel. When connecting aluminum wire to CO/ALR devices, it's important to use the proper size terminal for the wire size. The terminal should be large enough to accommodate the wire without over-tightening. It's also important to tighten the screws on the terminals to the manufacturer's specifications using a Torx screwdriver. Over-tightening can damage the wire, while under-tightening can lead to loose connections. In addition to using the correct connectors and devices, it's also important to consider the overall design of the electrical system when using aluminum wiring. For example, it's generally recommended to use larger gauge aluminum wire than copper wire for the same ampacity. This is because aluminum has a higher resistance than copper, so a larger wire size is needed to carry the same amount of current without overheating. It's also important to avoid mixing aluminum and copper wires in the same circuit whenever possible. If it's necessary to connect aluminum and copper wires, use a connector that is specifically designed for this purpose, such as a crimp-on connector or a listed transition connector. Finally, it's important to inspect the electrical system regularly for any signs of problems such as loose connections, corrosion, or overheating. If you notice any issues, have them repaired by a qualified electrician as soon as possible. By following these guidelines and best practices, you can safely and reliably use aluminum wiring in homes and buildings. However, it's important to remember that aluminum wiring is not a substitute for copper wiring in all applications. In some cases, copper wiring may be the better choice, especially in critical circuits or in areas where there is a high risk of corrosion. Always consult with a qualified electrician to determine the best wiring solution for your specific needs and to ensure that all work is performed in accordance with the NEC and local electrical codes. Let's examine the specific implications of NEC Article 310.15 in greater detail, breaking down its requirements and how they relate to real-world applications. NEC Article 310.15 is a critical section of the National Electrical Code that addresses the ampacity of conductors. Ampacity refers to the current carrying capacity of a conductor, or the maximum amount of current that a conductor can safely carry without overheating. Article 310.15 provides guidelines for determining the ampacity of conductors based on factors such as the conductor material, size, insulation type, and ambient temperature. When it comes to aluminum wiring, Article 310.15 is particularly important because aluminum has a lower ampacity than copper for the same wire size. This means that a larger gauge aluminum wire is typically required to carry the same amount of current as a smaller gauge copper wire. The NEC provides tables that list the ampacities of different types of conductors based on their size and insulation type. These tables are used to determine the appropriate wire size for a given circuit based on the expected load. For example, Table 310.16 in the NEC lists the allowable ampacities of insulated conductors rated up to 600 volts, based on their size and insulation type. When using aluminum wiring, it's important to consult these tables to ensure that the wire size is adequate for the intended application. In addition to the tables, Article 310.15 also provides adjustment factors that must be applied to the ampacity ratings based on factors such as the ambient temperature and the number of conductors in a raceway or cable. For example, if the ambient temperature is higher than 86 degrees Fahrenheit, the ampacity of the conductor must be derated to account for the increased heat. Similarly, if there are more than 3 current-carrying conductors in a raceway or cable, the ampacity must be derated to account for the increased heat generated by the conductors. These adjustment factors are critical for ensuring that the conductors do not overheat and that the electrical system operates safely. When working with aluminum wiring, it's important to carefully consider these adjustment factors and to apply them correctly to the ampacity ratings. Article 310.15 also addresses the termination of aluminum wiring. As previously mentioned, when using solderless connectors to terminate aluminum wiring, it's important to use connectors that are specifically listed for aluminum wire. These connectors are designed to provide a secure and corrosion-resistant connection that will not loosen over time. The NEC also requires that aluminum conductors be terminated in a manner that prevents the ingress of moisture and contaminants. This is typically accomplished by using a sealant or compound that is specifically designed for use with aluminum wiring. In addition to the requirements for connectors and terminations, Article 310.15 also addresses the grounding of aluminum wiring. The NEC requires that all electrical systems be properly grounded to protect against electrical shock hazards. When using aluminum wiring, it's important to ensure that the grounding system is properly installed and maintained. This typically involves using a grounding conductor that is sized according to the NEC and that is connected to a grounding electrode system. The grounding electrode system must be properly installed and maintained to ensure that it provides a low impedance path to ground. In summary, NEC Article 310.15 provides critical guidelines for the ampacity, termination, and grounding of aluminum wiring. By following these guidelines, you can ensure that your electrical system is safe and reliable. However, it's important to remember that the NEC is a complex document and that it's always best to consult with a qualified electrician to ensure that your electrical system is installed and maintained in accordance with all applicable codes and regulations. Let's elaborate on the historical context of aluminum wiring issues, the specific alloys used, and the evolution of connection methods to provide a more comprehensive understanding. The problems experienced with aluminum wiring in the 1960s and 1970s primarily stem from the use of a specific aluminum alloy known as A1350. This alloy, while being cost-effective, had a higher coefficient of thermal expansion compared to copper and was more prone to corrosion. The thermal expansion issue caused connections to loosen over time as the aluminum wire expanded and contracted with temperature changes. This loosening increased the resistance at the connection, leading to overheating, arcing, and potential fire hazards. The corrosion issue was exacerbated by the fact that the electrical devices and connectors used at the time were not designed for use with aluminum. This led to galvanic corrosion, where the aluminum reacted with dissimilar metals in the presence of moisture, further degrading the connection. Over time, the industry recognized these issues and developed new aluminum alloys and connection methods to address them. Modern aluminum alloys, such as AA1000 series alloys, have improved mechanical properties and are more resistant to corrosion. These alloys also have a lower coefficient of thermal expansion, which reduces the risk of loosening connections. In addition to improved alloys, new connection methods have also been developed to address the problems with aluminum wiring. As previously mentioned, CO/ALR devices are now required for connecting aluminum wire to receptacles, switches, and circuit breakers. These devices are designed to provide a secure and corrosion-resistant connection that will not loosen over time. Another important development has been the introduction of antioxidant compounds. These compounds are applied to the aluminum wire before making connections to prevent oxidation and corrosion. The antioxidant compound creates a barrier between the aluminum and the surrounding environment, protecting it from moisture and other contaminants. The use of crimp connectors has also become more common for connecting aluminum wire. Crimp connectors create a gas-tight seal that prevents moisture and contaminants from entering the connection. These connectors are typically used for splicing aluminum wire or for connecting aluminum wire to copper wire. In addition to these technical improvements, building codes and standards have also been updated to address the issues with aluminum wiring. The NEC now includes specific requirements for the installation and maintenance of aluminum wiring. These requirements cover everything from the selection of appropriate devices and connectors to the proper installation techniques. These changes have significantly improved the safety and reliability of aluminum wiring. While the problems experienced in the 1960s and 1970s were serious, they have been largely addressed through technological advancements and improved installation practices. Today, aluminum wiring can be a safe and cost-effective option for certain applications, provided that it is installed and maintained in accordance with the NEC and local building codes. However, it's important to recognize that aluminum wiring is not a substitute for copper wiring in all cases. Copper wiring still offers superior performance in many applications and is generally the preferred choice for critical circuits and in areas where there is a high risk of corrosion. Always consult with a qualified electrician to determine the best wiring solution for your specific needs and to ensure that all work is performed in accordance with applicable codes and regulations.